Okay, so last class I was focusing more on the basic, the fundamental MPLS. Today also we are going to do the same thing, but not theoretically. We are going to see those things that we have heard yesterday. Right? Number one, when I was saying that there will be a PHP on R4, what I meant is the labels will be removed, the MPLS header will be removed before sending to router 5. First thing I want to show you that trace route 5.5.5.5. If you notice, when the packet goes to 5.5.5.5, there is no label. Router 4 received with label number 405. It is because in R3 show MPLS forwarding table, the outgoing label for 5555 is 405. So outgoing label is nothing but the label given by router 4 to router 3. Router 3 has put this 405 and forward it to router 4. But to router 5, it didn't put any MPLS header. No MPLS header. How is that possible? Because of PHP. If you go to router 4 and check the outgoing label, you will know it. Show MPLS forwarding table. You see, it very well knows that I have to pop the label out before sending to F01 interface of this router 4 towards the destination 104505. It knows that I have to pop the label. I told you, label number 3 is involved to signal router 4 that router 5 is the ultimate final router. If you will send with label, then router 5 needs to do additional work which is unnecessary. Additional works like processing MPLS header and then processing IP. I told you, router 5 will not have an outgoing label for 5555. So it has to look into the routing table or the CEF table in order to take the exit interface. We'll also see the CEF table shortly. But before that, if I want to cancel this popping of label, what should I do? See, it is good to have this PHP. But if you say, no, I don't want to pop the label, it is okay if router 5 takes some extra load. If it does 2 lookups, MPLS and route lookup, I'm okay with that. End-to-end, I want MPLS. Yeah, of course, MPLS is running end-to-end. But if you feel like I want even router 5 to receive packet with MPLS header, then you should not send label 3. Instead, you should send some label ranging between 500 to 599, which is the range of label we have allocated for router 5. Now to do that, this is what the command. In the global mode, you say MPLS LDP explicit null. Advertise explicit null in the place of implicit null. Am I going to do that? Yes, this is the one. Boom. Let's see. I very rarely show this in the demo or teach this one. PHP I teach, but why to cancel PHP? No necessary. So I don't really teach this, but I remember hardly this is the command. Let's now go and clear MPLS. No MPLS, then no MPLS IP, then I'll put MPLS IP again. Okay, now I have refreshed. Let us see. Go to router 4. Earlier you were having pop label. Now let's see what it shows. Explicit null. Implicit null is meaning implicit means what? Without we saying, it was popping up the label. Implicitly it was doing. Null, it says there is no label to send. There is no label. Now I want to capture a packet in between 4 and 5 and see how the packet looks. This capture is after cancelling implicit null in PHP. Now I will again trace, or I'll ping this time. Now this is the ICMP packet. Stop or put ICMP. And this is the one. You see, it shows explicit null, meaning there is no label. Label is 0. This is not label number 3. This is label number 0. That is also one of the reserved label. In the MPLS header, you see an MPLS header. That is the negative part of you cancelling PHP. This is not actually cancelling PHP. It has not popped the header. Header still exists, but with the label 0. So I have cancelled popping. It says 0 label, no label, which means when there is no label, when the packet comes with no label, it has to automatically go to the routing table now. This is explicit after you cancel. Now let me put back the default. The default is implicit null, meaning popping up, label number 3 involving. I remove this, clear IP MPLS, clear MPLS LDP. No, LDP status I don't want. IP, LDP, IP. No. Better you do this. No MPLS IP and put MPLS IP back. That is best way of clearing. This is not a layer 3 protocol. It won't be much disruptive. Okay, now let's go to router 4 and see the forwarding table. Look at this, it is now saying popping label. Now let me do the same ping again. If you notice now, the last packet here, there is no MPLS header. This is real pop. This is reducing the load on router 5 because there is no MPLS header. Whereas if we go like 5 packet above, 1, 2, 3, 4, 5, this one, notice one more. This was having a a layer of MPLS, which is overload, which is unwanted load on the edge route, ultimate route. So better leave it default. Don't cancel the implicit null. Do not cancel PHP. Did you understand? That's great. Now, if you see the return packet going from 5 to 1, you see the MPLS header, and this header has got 4 fields. This MPLS header has got 4 fields. In the beginning of MPLS class, I was teaching you this theoretically. Now I'm showing practically. The header size is totally 32-bit, I told you. The total size of MPLS header is 32-bit. And if you see those things here, like 20 bits are here. 5 4s are 20 bits. And then 3 bits of experimental bit. This experimental bit can be used for QoS or some other experiment like upcoming features like or traffic engineering. That's the best example. All right, traffic engineering, you can use this. Now there is only one bit given for marking the bottom of a stack. See, the next topic will be our layer 3 MPLS VPN. Layer 3 MPLS VPN. Now, when you do MPLS VPN, there will be another layer of MPLS here. Same like this, you will have another layer here. That will have this bottom of a stack 0. Now I'm saying the opposite. That will have 1 and this will have 0. Actually, this will be on top and that VPN will be at the bottom. The one with the bottom will have 1. That is why it is called as bottom of a stack label. Bottom of a label stack. Bottom will have 1. The top will have 0. See, when you have more than one layer of MPLS, the router should know whether I'm processing the last layer of MPLS or the before one. To signal the router, this S bit is bottom of a stack bit is used. The VPN layer of MPLS will be having 1. And this layer which is using within the layer which is within the service provider to move the packet hop by hop will have 0. When we go to VPN, we will learn those things. Now, what I'm trying to say is there is only one bit needed to say whether it is the last one or the before one. Last one will have 1, before one will have 0. Binary 0 and 1, only 0 and 1, either this or that. Then the TTL is 255. What is this TTL? The time to leave, which is in the layer 3 header, is copied to layer 2.5 MPLS. So inside MPLS, the TTL will get decremented. And when it is going back to IP, it will copy back the TTL to IP. This reduces loops. TTL is very important in layer 3 header. So even in MPLS also we have that TTL so that you won't compromise with looping network. Yeah. So this is bottom of a stack. TTL, experimental bit label. 32 bit totally. MPLS is 32 bit. In which 20 bit is for label 3-bit is considered as an experimental bit, but currently what you are doing with that is, if you want to give quality of service for this MPLS, we'll use this. If you want to do traffic engineering, you will use this. And the bottom of a stack bit is only 1, and TTL needs to go up to 255, so the number of bits are 8. When you add and see, you get 32. You got it? Okay. Now, there are few show commands I want to show you before I take you to the next advanced level of MPLS. We are finishing up this fundamental, really important MPLS fundamental topic. For that, you need to know some show commands before we close this topic. Number 1, let me take the middle router so that you'll see the Ceph table I want to show you. If you see show IP route 5.5.5.5, you don't see any labels here. Do you see any labels here? No, there is no use of having label here. Why? The router is not going to see layer 3 engine, layer 3 output. It's not going to go through layer 3 engine. I told you yesterday there is Ceph which works in layer 2 acting like a routing table. So labels are attached to Ceph table. Now when I trace route, the label that was used for 555 before sending to router 4 is 405. I want that to be there in the router 3's Ceph table. Let's go check. Router 3, show IP Ceph 555. I want to see the label 405 there. You see there, 405. So when you enable MPLS, the Ceph table gets the label. Not only that, show IP MPLS forwarding table it's not IP, show MPLS. It's not layer 3. Forwarding table, you see local label as well as outgoing. Why local label is needed? Because router 2 will put this 305 and send to router 3. So it should know if I receive a packet with 305, I have to swap it with 405 and forward it out via this interface. There's also another command which is an MPLS database kind of command, show MPLS binding table. LDP binding. I want to see only for 555/32. Okay, don't put 32, simply put 32. It says the local label router 3 given is 305. The label received from router 4, the downstream is 405. Router 2 also have advertised to me that router 2 is using 205. You know why this is needed 205? 5 is in the other direction. Why there is a need for 205? If traffic goes, it will be going this direction. So router 3 needs to know the label of router 4. Why is there a need for this one? It is because in case if there is another connection like this to 555, if this link goes down, any traffic coming which wants to go to 555 can go like this immediately. It will be going this way, and when there is a break, fast convergence, it will go via the alternate path. For fast convergence, it learns everything in all direction. Whoever gives it will collect and take and keep. So it's not only for the downstream it maintains the label, it even maintains the label of the upstream. Do you understand this? Did you get this? All right. I think now we have come to the end of the fundamentals of MPLS. If you have any questions, you may ask. I'll help you to understand better. Your time. Show MPLS LDP neighbor. You see, router 3 has got a neighbor called 444. And from that neighbor, it learned about this particular prefix, this prefix, and this prefix. These are the three things that peer has got on its interface. These are the three IP address on connected peers interface. These are the three address on router 2's interface. That's how router 2 can be identified. Router 2 can be identified with this address, or with this address, or with this address. This is the address from where all the negotiation comes. Though router ID is 2222, the negotiation is coming from the R-bound interface. This router ID need to be a reachable address. That's why we run OSPF on all those loopbacks. Loopback is the one which it will pick as a router ID by default. But if you want to change it, you have a command, MPLS LDP router ID. Simple. You can put any interface address as a router ID. But leave it default, it is good for you. Loopback interface will be the router ID. If you don't have loopback interface, and if you want to use only the physical interface, then you need to mention which physical interface by using that command which I showed you. All right, so if no, then